Good afternoon, everyone. We'll now consider how to apply systems of linear equations to practical problems. If you have a problem that can be rephrased in terms of a system of linear equations, how can you do this, and how can we find the solution for the system of linear equations? Of course, we've considered how to find the solution using the four methods, which are the algebraic techniques, the graphical method, the determinants or Cramer's method, and the inverse matrix method. We'll now see how to rephrase a practical problem to be written as a system of linear equations, and then we will use these four methods. Any of them can be used to solve the system of linear equations. Our first example says a restaurant offers two different menus for prices 5 and 7 LE respectively. If the number of menus sold on a Friday is 600 menus and the total cost of these menus is 2,200 LE, determine the offered number of each of the menus that will make the profit of the restaurant equal to 1,000 LE on a given day. Usually this type of word problems is solved, the main trick or the main tip to solve them is to determine your variables, to define your variables. What is the x, what is the y, what is the z, how many variables do we have? And usually the clue is in the question itself. The question says determine the offered number of each of the menus. So this is the solution to your system, the number of each of the menus. And this leads us to the definition of x and y as x represents the offered number of the first menu and y represents the offered number of the second menu. Okay? And then after defining the variables, which is obtained from the question itself, the offered number of each of the menus, we go back to the question and try to write all the possible information that we have. The question says a restaurant offers two different menus for prices 5 and 7 LE respectively. If the number of menus sold in general, didn't specify the first or the second, the number of menus sold on a given day is 600. So on a given day, on this Friday, I can say that x plus y is equal to 600. Why? Because x represents the number, the offered number of the first menu, and y represents the offered number of the second menu. So if the number sold on Friday of both menus is 600, this means that x, which is the number of the first menu, and y, which is the number of the second menu, their addition will give me the 600. This is our first equation. The second equation is a bit tricky. You know that profit is equal to revenues minus cost, right? The question here gave you that the total cost of both menus on Friday was 2,200 LE, and that the price of each menu is 5 and 7 respectively. If you need the profit to be 1,000, this means that the revenues minus the cost is equal to 1,000, right? So what is your revenue? Your revenue is obtained by multiplying the price of the menu by its number. So for x, for the first menu, the revenue is 5, which is the price here, multiplied by the number sold of this menu. And for the second menu, the revenue is obtained by the price, which is 7, multiplied by the number of menus offered, which is y. This is the total revenue for both menus. The first part is the revenue for the first menu, which is its price times its quantity, and the second part here is the revenue from the second menu, which is also its price times its quantity. This is the total revenue for both menus, minus the total cost, which is already given in the problem. The revenue minus cost defines the profit, which is what we need to have here as 1,000. Okay, so here we have an easy equation that the number of both menus should be equal to 600, and here we have the revenue minus the cost equal the profit, giving me this equation here. How did we reach from this equation to this equation? We just removed the 2200 to the other side, okay? And this is what we call our 2x2 system that we need to solve. So the whole word problem here is summarized in the form or rephrased in the form of a 2x2 system of linear equations. You can then solve this system by any of the 4 techniques that we've covered. Okay, there is no restriction unless the problem says clearly that we need you to solve this problem using a specific technique. You can use any of the 4 methods, the algebraic, graphical, determinants, or Cramer's method, or the inverse matrix method. You can solve this system using any of the 4 methods that we've covered. Okay, so we have this system, and I chose to solve it using the inverse matrix method, but you can solve it using any other technique. Okay, to do this we need to transform or rewrite this system in matrix notation. So we would say that AX is equal to C, where A is the matrix of coefficients 1, 1, 5, and 7. X is the column vector of variables, and C is the matrix of the column vector of constants written on the right hand side of the equation. As we said previously, in order to solve this system using matrices, we need to get the inverse of the coefficients matrix A, and this inverse is easily obtained using the steps that we took before, which is first get the determinant, then the cofactor matrix, then the transpose of the cofactor matrix, and then multiply the adjoint or the transpose of the cofactor matrix by 1 over the determinant of A, and this is the result, which is A inverse. Please do this manually and double check that this is what you get if you try to get the inverse of the matrix A. And to double check again then this value is correct, you will multiply A inverse by A, and to make sure that you get the identity matrix of order 2. And of course this scalar value here, the half, is multiplied by matrix, which in other words mean that we need to take this scalar and multiply it by each and every element inside the matrix. Okay, once we got the inverse, the solution is written as X equals A inverse multiplied by C. So we just multiply the matrix we got here after multiplying the half inside, and then we multiply the A inverse by C. How do we do this multiplication? We just take this row multiplied by this column to give us the 500, and take the second row multiplied by the only column we have to give us the 100. In order to make sure that this is the correct solution, you go back to the original system and you double check that these values for X and Y satisfy these 2 equations simultaneously or at the same time. Because this is a word problem, you have to say at the end that the restaurant should offer 500 of the first menu, which is corresponding to the value of X, to our definition of the value of X, and the restaurant should offer 100 of the second value of the second menu, which is the value of Y. Okay, we'll move on to the second example. The second example is, it says a factory produces 3 models of cars. The total cost to produce 200 such cars is 3 million LE. If the unit cost of the 3 models is 10,000, 15,000, and 25,000 LE respectively, and we know that the number produced of the first model must be twice that of the second model, find the number of cars produced of each of the 3 models. Again, the clue for the solution is to correctly define your variables. How many variables do you have, and what is the definition of each of the 3 variables, of these variables. from where do we get this information? Usually the clue is the solution, or what the question is asking for. Find the number of cars produced of each of the three models. This means that we want to know the number of cars produced of each model, so we can define our x to be the number of cars produced from the first model, y to be the number of cars produced of the second model, and z be the number of cars produced of the third model. And from where did we get this piece of information? From the question itself. Usually what the question asks for should be your variables, because this is the solution of the system that we aim to find. Now we'll try to rephrase each statement in the problem and rewrite it as an equation. We have three variables, so we are expecting three equations. The first piece of information says we have the total cost to produce 200 such cars. So how many cars is this factory producing in total? 200. If x is the number produced from the first model, and y is the number produced from the second model, and z is the number produced from the third model, this means that our first equation would be x plus y plus z equals 200, because this is the total number of cars produced from all the three models. The second equation will be obtained from this statement if the unit cost means the cost of producing only one unit of the three models is 10,000, 15,000 and 25,000 LE respectively. We said that the total cost is equal to 3 million, and this is the cost of producing one unit from each model, which means that our second equation will be 10,000, which is the cost of producing only one unit from the first model, times the number of units produced from model number 1, plus 15,000, which is the cost of producing only one unit from the second model, times the total number of units produced from model 2, plus 25,000, which is the cost of producing only one unit from the third model, times the number of units produced from the third model. This will be the total cost of all the models produced, so it's equal to the 3 million here. Okay, so the second equation is the total cost of all the three models, so we get the cost for the first model as the unit cost times the number of units, the cost for producing the second model, which is the unit cost times the number of units, and the cost for producing the third model, which is the unit cost times the number of units. Our last equation is obtained from this information. The number produced of the first model, which is x as we defined it, must be twice that of the second model, which is y. So our third equation would be x equals 2y. What about z? It will not appear in this equation. Okay, if the number produced from the first model, which we defined as x, equals twice the number produced from the second model, so this would make it x equals 2y. And now we have a system of three equations in three unknowns. But in order to make the second equation a bit easier, we can divide both sides of the equation by 5,000. Okay, giving us this simplified equation, 2x plus 3y plus 5z equals 600, and now we have a 3 by 3 system of linear equations. We can solve this system using any of the methods that we consider. If I chose here to solve it using the inverse matrix method, then all I need to do is to write the system of linear equations in matrix form, which is ax equals c, where a is the matrix of coefficients of the system, here the coefficients, and the coefficient of z in this equation would be 0. Then this is the column vector of variables, and this is the column vector of constants. This is our first step. Our second step is to find the inverse of the matrix A, the matrix of coefficients. And now we know how to get this inverse. The first step is to get the determinant and make sure that it's not equal to 0. And then we get the cofactor matrix. and then we get the adjoint matrix, which is the transpose of the cofactor matrix, and then we get the inverse as 1 over the determinant of A multiplied by the adjoint matrix we obtained here. So we have the A inverse as this matrix, and to make sure that it's correct, you can multiply the A by A inverse and make sure that you will get the identity matrix of order 3. Okay, our third step is to find the solution, the x, and this is obtained through multiplying A inverse by C. This is our A inverse, and this is the column C, and we get this multiplication through multiplying the row by the column, the first row by the column, the second row by the column, giving us the second value here, and the third row by the column, giving us the third value here. And this will give us 100, 50, and 50. Which means that the solution for this system of linear equations is x equals 100, y equals 50, and z equals 50. And this means that the factory should produce 100 units of the first model, 50 units of the second model, and 50 units of the third model. And again, to make sure that your answer is correct, you can substitute these values in the left hand side of the 3 by 3 system of linear equations that we have, and make sure that the values satisfy the 3 equations simultaneously and gives you the values on the right hand side of the equation. Okay, thank you.